Welcome to Saxon Math, Lesson 92, Percent of Change. I'm Mr. Pretry, and we'll be starting with the mental math, so please make sure you have that finished and that you're ready to check it. So if you have not done the mental math on page 636, please do. Come back. Okay, so positive and negative numbers. So we have two negatives, which essentially makes this negative 75 plus positive 50, which sends us this way on the number line to negative 25. Order of operations, exponents. So looking first at our 1 5/10 times 1 5/10. We're essentially squaring that. I can just do some quick mental math and think that half of 50 is 150. Excuse me, half of 150 is 75. So half of 1 5/10 would be 75 hundredths. And essentially what it's asking us here is what is half more of 1 1/2. So 75 hundredths plus 1 50 hundredths essentially is 2 25 hundredths. Then looking over at our exponents, we can say that it's 2 25 hundredths times 10 to the power of, and we're adding two negative exponents together because we're multiplying these, gets us to the power of 10, power of negative 10. Okay, C, algebra. Well, we can already look here and say minus 2 from each side. That can just get us quickly to 48 equals 3 times m. Divide each side by 3. We'll get you 16 equals m. All right, mental math. You can think that 6 times 3 1/3 is like 6 times 3 plus 6 times 1/3. So, well, 6 times 3 is 18. And we know this is essentially asking us what is 1/3 of 6. 18 plus 2 is 20. All right, so 3 meters, or sorry, 3/10 of a meter converted to centimeters. Well, how many centis are in a meter? So we can take this and think that we are multiplying it we say boinky, boinky, gets us to 30 centimeters. Next, percent. $6 is 10% of M. Well, so isn't that just saying $6 times 10 is $60. Geometry. What type of angle measures 180 degrees? Well, let's see what a 180-degree angle would look like. It looks like this. How would we describe a line, a segment that looks like this? I would say it looks pretty straight. It's a straight angle. Okay, at $8 per hour, how much money will Kenji earn working 4.5 hours? Well, it seemed like this was simpler to just convert it quickly into decimals. So 4.5 times 8. I put where I've got a little more space. 4 5/10 times $8. Gets us, boinky, you see this, so put that here, gets us to $36. Okay, let's go on to our examples. Now, I think it might be good for me to start with a couple of very simple of my own examples because theirs are going to get interesting very fast. So what we're studying today is the percent of change and measuring changes in our reality. So I love this. This is a very math sciencey kind of lesson. And so if you're measuring change, no matter what that is, you're starting with an original number. And then you might be, depends, could be adding an amount of change, some sort of quantity, or subtracting if you're decreasing. So an original number and an increase of the amount of change will get you a new number. An original number and a decrease will also get you a new number. Now, this first chart is kind of more like the ones that we've already been doing. And so maybe a kind of problem we could be working on is to think about, say, the percentages and actual counts of a condition, such as we could maybe think that last month, now, none of the talk about rain I'm about to do is based on any sort of real measurement. I am totally coming up with this off the top of my head. So don't think this actually applies to our last couple months of weather, say. So if you were trying to track how many days of rain and how many days of sun, let's say in last month, say in March, we could say that we knew that 10% of the month was rainy, and then that left 90% as nice sunny days. Then thinking in terms of trying to figure out, well, how many days during the month, say if there were 30 days in the month, then that could be the whole. And if we knew that 3 days, if we knew that 10% of those were rainy, then 3 days would be rainy. And subtracting those two can figure out that 27 of the days were nice and sunny. Now, what we're talking about this lesson, though, this is not this lesson. This is the type of lesson that we've been doing. But what we're doing this time is we're taking an original amount and applying a certain amount of change and figuring out what the new conditions are. So maybe we could think of a different type of example that would more reflect this. Now, say that what we were talking about was the actual amount of change in rainfall between last month and this month. So let's say that last month it rained 10 millimeters. And say we knew that there was a 50 a plus 50, a 50% increase in the amount of rain from last month. Well, things that we already know is that the new percentage that we're going to have after the change is 150% of the original. Now, one way I thought to just quickly mental math using the change is we could just say to get a 50% change, multiply that 10 by 0.5, five tenths, or 50 hundredths. And that will get you a change of plus 5 millimeters. And so the new amount of rainfall for this month would be, there was 15 millimeters of rainfall. All right, let's go take a look at the book's examples. The county's population increased 15% from 1980 to 1990. If the population in 1980 was 120,000, what was the population in 1990? Okay, so plugging all this information in. So we know that the original actual count of people was 120,000 people. We know the change was an increase of 15%. So another thing that we know is that the new percentage will be 115% of the original. And things that we don't know are the amount of change and the new amount. So the numbers we can plug in, let's say to get the new amount. So we can take these across the top and these across the bottom. So bringing these over to here, we can say 100 on this side of our equal sign and 120,000 on this side. Then bringing ours from the bottom, we can say that the 115% working as a ratio of the original 100%, and then that will be essentially an equal ratio to 120 to the new number. So what will that look like when we do some cross multiplying goodness? Well, we'll have 100 in on one side of our algebraic equation equals 120,000 times 115. And for the purpose of not sitting here too long, I'll just do spoilers. It's 13,800,000. But of course, working with the number 100 kind of simplifies things. We can sort of erase zeros, but it's not really erasing zeros. Remember, we're dividing each side by 100. But just saving it with a step of mental math, which means I can erase 2 zeros from each side. I'll put in some new commas. Gets us n equals 138,000 people. And with that amount of information, you can even do a little bit of quick mental math to realize that 138 minus 120 is 18,000. And so we have an original population of the county was 120,000. There's a change of 15%, which was 18,000 people increase. So our new population in 1990 was 138,000 people. Example number 2. The price was reduced 13%. I can already tell that the price is probably our actual count for the percent. And if the sale price was $24.50, What was the original price? Filling in our spaces here. This is going to be a minus 30% from our original 100%, getting us, the price was 70%. There's our change. So if the question is, what was the original price? Then we're going to be bringing that, and we can use these across the bottom to be our additional information. And we'll have these across the bottom. So bringing in our 100% and our actual amount for the original. And that's a ratio to 70% is the new price. And the real price is $24.50. So making an equation from there. We bring these two. Oh, excuse me. We do our cross multiplying goodness. Getting us 70 times R equals $2,450. Then we can divide each side by 10. And divide each side by 7. And just going to do spoilers. This would end up being 35. And so we can say that the original price was $35. Now, if at this point you wanted to get up and do a little exercise and come back, I would not blame you at all. But here we go. Example number 3. A merchant bought an item at wholesale for $20. So that will be our original. And marked the price up 75%. What an industrious individual. To sell the item at retail. We'll say R, retail, is the new price. What was the merchant's retail price for the item? So this time we're trying to figure out this one. So, just looking at the information that we have, we can say that this is 175% of the original price. And we can say M for markup. And then plug these numbers in. So once again, we can bring these across. We can bring these across. So we'll have our 100%, which, you know, it kind of makes things simple when you're always working with 100 in the problem in there somewhere. And then 175% is our ratio to that. And then $20 is equivalent to the 100% across the top. But we want to know what the new retail price is going to be. That coincides with the 175%. So yes, some cross multiplies. We get 100 times R equals, spoilers, 3,500. And, well, we just need to divide each side by 100, which means erase 2 zeros from here, erase 2 zeros from there. Gets us R equals 35. Or the new price is $35. Yeah, don't think I didn't notice that $35 keeps on coming up, doesn't it? I don't know what's up with that. All right. Well, thanks for sitting through all these examples. And now, if you're with me, Mr. Pretry, you should be going to do the practice set, and then we will have an in-class discussion about that and do those out together later on at 1 o'clock. So, you have a wonderful day, and I'll see you later. Bye.